Definitely.
Okay, well, it sounds like we have a caller.
Yeah.
Hello.
A call-in question. So hello. Hello.
Hello there.
Hi. Thanks
Hi.
for calling Homework Hotline.
My name is Jeff Barratt.
Oh, hi. How are you?
I'm doing very well, Becca. So I have a question for Sam, actually.
Go
Okay.
right ahead.
So I have a piece of equipment at one of my campuses at Osage that is from 1917, and it is a refrigeration system. It uses, the technology is like an absorption refrigerator, and it uses ammonia and hydrogen and water,
Oh, okay.
which is heated,
Mm-hmm.
and it creates a cooling effect. How the heck does that work?
Okay, yeah, so let's see. So if it's ammonia and hydrogen, I don't know the exact chemical reaction, but essentially what's happening is you're going to be creating some kind of a compound in the chemical reaction that's going to add, I believe, an additional chemical bond. So if we're going from ammonia, which is NH3, and we're adding hydrogen to it, we're probably creating something like NH4. And in that process, energy from the environment is taken in to help create the bond, which makes it an endothermic reaction.
I was just going to say that. I knew that.
Oh, nice. Well, Jeff, I should have let Becca answer this. But essentially,
I should
it's
start answering these questions.
we should trade up a little.
No,
science
maybe
and
Start
math,
today
no?
for the
Maybe
last
not.
show.
I could do a squared plus b squared equals c squared questions.
There you
Knock that
go.
one out.
Well, sorry to interrupt,
No,
but
no,
I
not
was
at all.
just so excited that I...
So again, I don't know the exact formula. I'm really interested in looking this up now, but it's going to be some kind of reaction that creates an additional bond. Bond energy will be stored from the environment, which is endothermic. It's taking in energy, which is removing energy from the environment, which is going to leave things cold. Does that make a little bit of sense?
Yeah. From what I understand is that the ammonia in the liquid, the water, remains at the bottom. The
Okay.
hydrogen is now separate, and ammonia is now mixed with water. So the next step, as I understand it, is separating the ammonia and water, and heat is applied, which the higher boiling point behind, and vapor and bubbles remain, and then water's removed, and somehow it condenses and cools in this process, and then it cycles through and repeats.
Oh. Okay, that is really awesome. That is a little bit different than what I was thinking. You said this is called an absorption
Refrigerator.
refrigerator. I've
In
never
the
heard.
early part of the 20th century, it was used quite a bit.
Oh, wow. Well, that's really awesome. I'm going to have to look into it.
All right.
Well, thanks so much for calling in, Jeff.
Thank you.
Take care. Nice.
That, yeah. What is Jeff's title? Jeff Barratt? He's the
He's the executive director.
of Emily Griffith Technical
Oh,
College.
of UGS. I figured he had
so-
to be one of your guys' folks.
Yeah. So yeah.
Cool. Very
So
neat.
he had a science question for you,
Awesome.
and I kind of knew the answer. I guess not really.
Yeah, it seems like it
endothermic,
actually
like-
works by a different process than I was thinking.
But that was my thought, was that it was endothermic.
So,
was
and
like,
I maybe
how
should have
can
kept
it
him on
be
the line
cold?
to talk to them about this, but yeah, I guess if it's it sounds like it's actually using absorption of energy through phase change. So, like for example, when water turns to steam, like sweat on your body, that's a phase change that absorbs energy, which is why sweat is cooling on the outside.
Oh,
So it sounds
okay.
like that's what it actually is, that it's some combination of two chemicals that leads to a situation where as one moves from liquid form to
Liquid
vapor
to
form,
gas.
that is what actually pulls the energy from the environment.
Very
So,
interesting.
I'm gonna have to look into it.
is,
I
yeah.
just don't know, but yeah.
Not an expert on century-old refrigerators.
I'm not. You would think I'd know more about this, but sadly no.
Century-old ones.
Right, right. Yeah, that is a century ago now. Holy
Almost.
crap.
Pretty close.
Whew. All right.
Cool.
Well, let's go back to Antonio and get another question. Pull one from social media.
We got another science question. It asks, what element is most common in Earth's air?
Yeah, the answer to that question is nitrogen.
I knew that one too.
Oh, that's just Becca. Just
But I
take
learned
over.
it from you.
Oh, did you learn it
I
from
did
me?
learn it from you.
Well, good. Maybe what we can do is if we just do enough shows, you guys will know enough science that you
That's
can
true.
just
Yeah.
take it from there. Let me look at, I'll just pull up a graph that'll sort of show us here the different breakdown. So, okay, about 79%, I want to say, 78% of Earth's atmosphere is nitrogen gas, 21% is oxygen gas, and I think I've mentioned this on the show before, but there's this common misconception that, oh, since we breathe oxygen and that's the air we're breathing, and we're using the oxygen, and that must be most of the air around us. But in fact, most of the air around us is this N2 nitrogen gas. Nitrogen gas is really non-reactive. I think the reason that I talked about this last time was because of this. One of the nice things about, oh, you know what it was? It was talking about pumping nitrogen gas into tires. You guys remember that?
I remember that.
That's what it was. And the reason is that nitrogen gas is really non-reactive, which is useful. It's this gas that floats around is just inert. We say it doesn't react with things, so it doesn't have really positive or negative effects. It's just sort of filler. And that's actually a really good thing. Increased levels of oxygen in the atmosphere, they could increase to a point where it would actually be unhealthy for us. And not that I would necessarily mind this, but if oxygen levels were even slightly higher than they are, insects would be much, much larger than they are. So insects absorb oxygen through their skin or through their bodies, right? And if oxygen levels are low enough, insects need to be small so that the surface area to volume ratio is such that they can get enough oxygen to all parts of their body. But as oxygen levels increase, all of a sudden it's okay for insects to be larger, reduce that surface area to volume ratio. And so at times in Earth's history when oxygen levels have been larger, there have been much, much larger insects, which would be cool, but also might, again, bother some folks. But yeah, the answer to the question was nitrogen gas.
Do you know anything about nitrox scuba diving?
I
that works?
don't know about nitrox scuba. I know about nitrogen gas in scuba diving and the bends, but I don't know what nitrox scuba diving is. Do you wanna
Okay, I guess kind of what it is, and this is I was just kind of curious if you knew how it worked. So a scuba diver can extend their safe bottom time under the water by adjusting the ratio of oxygen to nitrogen in the scuba tank.
Yeah.
And increasing the level of oxygen, decreasing the level of nitrogen.
Huh.
So they can spend more time safely at the bottom and not worry about something like nitrogen narcosis or the bends.
Yeah. I guess that's just because you would have less total
Less
nitrogen,
nitrogen,
and
yeah.
so the time that you would need to work it out of your system as you're doing the slow
Right.
rise back to the surface would be less. I'm guessing that's the
And
reason.
less building up in your system.
Less
because
building
there's
up in your
less.
system, which gives you
Yeah.
more time.
Okay.
It's got to be something like that.
Yeah. It's interesting.
Yeah. Okay, cool. Well, I don't know if we talked about that on the show, but at some point maybe we should talk about the bends and how that works.
I was
Yeah,
kind
that'd
of
be
thinking
interesting.
that. I would like to know.
Yeah.